machine learning model or a deep learning model for your purpose, right? And the key concepts we have discussed so far is neural network scale from simple neuron to very deep stack, and it is actually utilized for different applications based on the data we have, right? And these are some examples you can actually see. Okay, you can actually see how the deep neural networks and the machine learning techniques are utilized for different scientific discoveries, right? This is a very prominent problem, okay, protein folding problem. This protein folding problem is actually was a nightmare for different decade. Okay, so how this protein folding was solved? The protein folding was solved with a with a very particular technique called deep neural networks or a deep learning techniques, which is able to predict how the proteins are getting folded. Okay, and the major application we can see worldwide recognized as AlphaFold. AlphaFold is a tool which utilizes deep neural networks for predicting the protein folding problem. Okay, and you may be heard about David Becker 2024, they got Nobel Prize in Chemistry for finding this for solving this protein folding problem or the protein structure prediction by leveraging artificial intelligence. Okay, and material discovery is another area. If you are from a material science or a physics or a chemistry background, you can actually see the different composition of different chemical components will give different properties for a material, right? So finding an optimized composition of these materials or or these components to build a new material is a very difficult task. And we are actually utilizing a very sophisticated kind of neural network, which is called as graph neural net for leveraging it for material discovery. This is some existing work which utilizes graph neural network for finding the material properties for a new material. Okay, and even in astronomical signals, we can actually see there are a lot of applications where established with the help of neural networks and other machine learning techniques. Usually the anomaly detection in the astronomical signals, or see, this is what we are calling as space object detection. Okay, if you are having the image, photometric image of a space object, we can actually predict it as a meteor or a planet or a moon or a satellite or a galaxy, something like that, right? So we can actually build uh, deep neural networks or any machine learning pipeline for doing such kind of astronomically uh, needed task. Okay, and you may be familiar about the large language models, right? So can you tell me one example of large language model? Large language model.
C++.
Ma'am, can you repeat? I'm not understanding you.
C++.
Large language model. Actually, C++ is a programming language. A large language model is Google. Are you answering it as Google? Okay. See, yeah, it's actually not a programming language. Okay. Maybe you will be having your phone with you, right? Are you having your phone with you?
Yes, yes.
Can you just go to WhatsApp?
Yes, sir.
Please move to any chat window, any person's chat window, and type what I'm telling. Hi, HI, how, 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 space
Just
R,
sir.
yeah, hi, space, hi, comma, space, how, HOW, space, ARE, space. Okay, post at that point. And most of you are getting a suggestion on your keyboard, right? That word is you. Is that correct? On your
Pardon,
phone's
pardon
keyboard?
me, sir. Pardon me, sir. I'm not having the phone, but I'm doing it in laptop. Is
Yeah.
it possible to have?
You
This
can
is
actually try with your phone. If you type
the
simply
suggestion is you.
Yes.
you. Yeah, that is what I'm telling. The suggestion is you. So I'm asking you how your keyboard is actually knowing that I'm going to tell you, because it is having a kind of intelligence, right? That intelligence is actually made on text. Okay. And what is this kind of intelligence are called? That intelligence is called as language model. Okay. Language models are nothing but if you give a sequence of words, that model is able to predict the next word, the word of that sequence. Okay. See, fortunately, such a capable language model is actually we have now is actually the ChatGPT. Okay, ChatGPT is nothing but it is a language model, and particularly it is called as a large language model. Okay, particularly a large language model. So this large language models are very useful. Okay, large language models are very useful and very powerful tools in the space of scientific discovery as well as this inventions. Okay, see, if you have a chat gpt or maybe gemini or any kind of perplexity cloud or google LF, any of these tools, you have such a tool, you can actually simply uh, have a brainstorming with that tool, right? If you have a research paper with you, you can simply upload it. You can have a brainstorming with that particular tool, right?
Yes.
So such a capable tools are actually now available. So a large language model is an AI system that can read, write, and reason with text by predicting the next words in a sequence after being trained on a huge collection of text from the internet, books, and other sources. So if you have LLMs and LLMs enable tools, if you have some data, you can actually do some summarizations, you can set hypotheses, you can even set do perform experiments with it, right? So the nowadays one of the breakthrough we are having in the in the domain of scientific discovery is nothing but LLMs. Okay, and see why we have to bother about two terms, that is explainability and interpretability while dealing with machine learning for scientific discovery, because these are two keys that will give you the reliability on the results you are actually creating, right? Because most of the machine learning techniques are not transparent. They are all black boxes. Because if you give an input, it will simply give some output, but it is not able to explain you why that output is generated, right? So if you are inducing such a capability of explaining why you got that output, okay, that is what we are calling as explainability, or collectively we can say it as an interpreter. So the output from an AI model should be validated. That for that validation, the model itself should be capable of explaining the results or interpretability, providing interpretability on the results. Why that particular output is getting generated. So while choosing machine learning model for scientific discovery applications, you have to keep in mind that models, the choosing models are quite fairly explainable or interpretable. Okay, and the next level of scientific discovery that is happening in our technology spaces, the self-driving labs, because we are having a physical lab setup, but there is no human involved in it. A robot will be there, and that robot itself is doing the measurements, creating new data, performing the designs, plans, setting the hypothesis. Everything can be done with this self-driving labs. This is a closed loop lab, right? And the technique, with the machine learning technique we are using here is actually called as active learning. Okay, active learning technique to choose the next experiments for scientific discovery. Okay, so it's a self-driving loop is a closed loop AI system that perceives, decides, and acts autonomously, and it continuously improves through feedback from its action, similarly to how humans learn. And this can be relatable with the word agentic AI. Maybe you are all listening to the word agentic AI, right? So this is very similar to that agentic AI. And the next kind of exploration we can do is human machine collaboration, right? By using the AI systems along with the human capabilities, it can actually we can actually go beyond the boundaries now we have set that in the scientific discovery and innovation. See, a scientist can actually set goals and priors, and based on that, AI can generate suggestions and predictions. So the human machine collaboration combines the creativity, intuition, and ethics of a human with the speed, precision, and pattern recognition of a machine. Okay, so it is not rather than replacing human, AI augments decision making and productivity for the human task. Okay, so in this particular way of utilizing artificial intelligence, the responsibility of human is to define a goal, provide context, interpret results, and ensure ethics. And the machines will perform data analytics, learn from the patterns, and it will suggest or automate actions. Okay, fine. And what are the key challenges in AI and machine learning while using the scientific discovery? There are three different kinds of challenges: the technical bias, the technical challenges, the societal and ethical challenges, as well as the operational and environmental challenges. The technical challenges includes the data bias. Suppose if you are having a wrong data for modeling a particular scenario, that will also give a wrong model, right? So the bias in the data will create issues. The interpretability, as I said, how the model is actually creating the output. It should be explained. That interpretability, reproducibility of the current experiment. So these are the technical challenges we have, even though we are having efficient methods. Okay. And the societal and ethical challenges are in another dimension. That is the accountability. Who is responsible for decision? We cannot say it in the case of AI. Fairness and ethics. We have to ensure the models are fair and ethical. And the privacy, the risk of data misuse and leakage is also there with the uh, use of AI in this kind of application. So there are societal and ethical challenges. And the last one is the operational and environmental challenges. Maybe you may be heard about the sustainability issue or the environmental issues happening with large language models, right? See, if you're simply chatting with a chat GPT, a single query itself is actually creating a huge pollution. Okay, huge pollution. So these are the operational and environmental challenges for this particular system. Okay, so what the future vision is, see, we can actually put the human in loop with AI systems. See, what human can actually do a collaboration for generating the hypothesis, okay, along with AI, and the autonomous labs will generate 24 by 7 experimentation because they will not get tired and they will not get exhausted. It can do a lot of experiments. The morning insights are the analyzed results. The human can interpret and create results on the particular experiments. So this is how the future scientific discovery and the innovations are actually going to happen. And the domains like biology, material science, energy, climate, space, humanities, art, literature, everywhere we can actually leverage the application of machine learning for different uh, innovative practices as well as knowledge discovery. Okay. So the closing thoughts, I think the time is over. The machine ML is a new lens for science. It will help us to find patterns, generate hypotheses, and design engine. The human judgment plus machine exploration will amplify the curiosity. And the next decade, the closed loop and the interpretable responsible AI is actually the promising words for the future. So thank you for patiently listening for this much time. I, uh, I hope you got some ideas about what I am trying to convey. As we are having a short span of time, I try to include a richer content. So hope you got caught up with this. Okay, thank you.